Shall we start or wait 1-2 minutes?
Yes.
Okay. So thank you for your acceptance. And it is our first forum. And the first forum is about collection and reuse of greywater in agriculture.
Yeah.
This forum will be presented by Ulku Dagdelen, Dogan Dagdelen, Ferda Nur Özdemir, and Cenk Keskin. I think the Dr. Ulku is your first presenter. So please, you can start.
Mhm. Hi, good morning, everyone. My name is Assistant Professor Ulku Dagdelen Yılmaz. Could you see my screen and is there any problem to my voice?
No, I can hear and I can see the slides, but you can go to presentation mode.
Okay. Yeah.
Yeah, it's perfect.
Okay. Today we will talk about collection and reuse of greywater in agriculture. We will discuss about the importance and greywaters and reuse in. Sorry. I will continue this. Okay. At first, I will I will talk about collection and reuse of greywater in agriculture and its importance. After me, my colleague Doğan will present about use of greywater in livestock farms. Then my colleague Cenk will present about use of greywater in crop production. And the last one is my colleague Ferda will present about economic investigation of the use of greywater in agriculture, and we will finish then our workshop. Our aim is to promote the sustainable use of water resource. We will give information about what's the greywater, its advantages, its importance, treatment methods, and application examples. The importance of water for people and planet and greywater. Water is vital resource for all living things and forms the basis of life on Earth. Approximately 16% of the human body consists of the water, and we need clean water for our daily activities. Water is indispensable for economic activities such as agricultural production, industrial activities, and energy production. Water resources are vital for sustainability of the ecosystems and biodiversity. With the global climate change, the production of the clean water resource has become even more important. Importance of water resource and global water crisis. The importance of water resources. Water is foundation of all life on Earth. Despite fresh water comprising merely 2.5% of our planet's total water supply, it plays an irreplaceable role in sustaining human civilization and natural systems. Access to clean drinking water stands as a fundamental human right and underpins sustainable development. This precious resource drives global economies, powering everything from farming to energy generation. The global water crisis affects nearly 2 billion people who struggle to access safe drinking water. This challenge intensifies as climate change accelerates, water sources diminish, and pollution contaminates existing supplies. The growing process of urbanization and expanding industrial activities place an ever-increasing strain on clean water resources. As water scarcity worsens in stressed regions, it threatens agricultural productivity and undermines food security, creating a cascading effect on communities worldwide. Causes and consequences of water shortage. Reasons: unplanned urbanization, overconsumption, industrial wastes are one of the main reasons. Results decrease in food production, health issues. There will be economic losses after this. Solutions, water saving, efficient irrigation techniques, and the important one and our subject, the use of grey water. Strategies for sustainable water management. The first one, water saving. It's important to reduce water consumption in homes and our workplace. Efficient irrigation, efficient use of water should be ensured throughout techniques such as drip irrigation, and the last one is use of grey water. What's the grey water? I will explain about this. The grey water is household waste water from sources such as showers, sinks, washing machines, etc., and does not contain toilet waste. These waters can be reduced in garden irrigation, toilet reservoirs, and other areas after appropriate treatment processes. Grey water recycling contributes to reducing freshwater consumption and sustainable use of water resources. The first one, toilet flushes. Grey water can be used instead of clean water in toilets. The second one is agriculture, we will talk about. And the third one is industrial usage. It can be used for different purposes such as cooling water and cleaning. The first one is toilets. Approximately 13% of domestic water consumption occurs in toilets, and the use of grey water in this area provides significant savings. Grey water from showers, sinks, and washing machines can be used in toilet tanks. We can see this rice link in this figure. This application contributes to the protection of the water resource by preventing unnecessary use of water of drinkability. Grey water collection systems can be integrated into buildings with appropriate piping and filtering equipment. Planning grey water systems with appropriate pipes and filtration process optimize installation costs. And advances in agriculture. As the global demand for water grows, agriculture faces increasing pressure to find sustainable solutions. One promising answer lies in grey water, a resource that can help address water scarcity while supporting food production. With proper filtration, grey water retains nutrients like nitrogen and phosphorus, making it a valuable resource for plants while reducing the need for chemical fertilizers. In water-scarce regions, grey water offers a sustainable alternative to fresh water for irrigation. Treated grey water provides essential nutrients to crop while cutting down on freshwater consumption. However, untreated or poorly treated grey water can carry harmful pathogens and chemicals, making proper filtration and disinfection critical to ensuring crop safety. Grey water also works well in hydroponic systems where plants grow without soil. Treated grey water's nutrients support plant growth, reducing the need for synthetic inputs like fertilizers, Using grey water in agriculture doesn't just save water, it also reduces the carbon footprint of irrigation systems. For example, in region Qatar, grey water irrigation has been shown to cut water-related carbon emissions by up to the percentage 20. Grey water isn't just wastewater, it's a sustainable resource for agriculture, from irrigation to hydroponics. It provides a pathway to conserving water, extending crop growth, and reducing environmental impact. Together, we can turn grey water into green solutions for the future of farming and our planets. And the industrial use of the grey water, industrial cooling systems, for example, milk tanks, air conditioning systems, climate air conditioner, and the power point cooling towers. Greywater application in the world, in some regions, housing projects, agricultural practices, and some school projects. And greywater potential for the sustainable agriculture. Greywater has an important potential for sustainable agriculture. It's an effective solution for protecting water resource and increasing productivity. It offers an environmentally friendly and economical option with the right applications. Thanks for your participation and thanks for your listening. Thank you. See you, Taner and Hamidana.
Yeah, thank you, Ulku. So I can't follow who is the next one, or
Yeah, and the
maybe
next,
we can ask further questions and comments maybe after the all
yeah,
presentations.
okay. Now Doğan will present about use of greywater in livestock farms.
It's right, Dogan Dagdelen, I guess. Yeah.
Yeah,
Hello,
Doğan.
everyone.
Hello.
I'm sharing my screen. Is it seen?
Just 1 minute. Yeah, it's coming. Yes. Yeah, it's okay. So you can change to your presentation style. Yeah, yeah. Now it's better.
Okay. Yes. Hello, everyone. My name is Doğan Yılmaz, and as an assistant professor in Animal Science Department at Atatürk University in Turkey, I focus on sustainable livestock management. Today, I will discuss greywater in use in livestock production, a sustainable approach, exploring its benefits, applications, and impacts on farm management, livestock farm management, and animal health. As you know, water is a fundamental resource in livestock production, but its increasing scarcity necessitates alternative solutions. One such approach is the use of greywater, recycled water from household sources such as sinks, showers, and laundry. This presentation explores the advantages, applications, and potential impacts of greywater use in livestock management. Greywater is usually seen as a waste, but we will discuss how it can be used again to protect our water resources. We will also look at the benefits of greywater and how to reuse it. The integration of greywater into livestock operations offers multiple benefits. Saving water by conversation, the use of greywater reduces the pressure on clean water resources. This is especially important for water-scarce region. The use of greywater in livestock farms can reduce freshwater consumption by 30 to 40%. Cost reduction using less fresh water means you pay less in bills. This means we have less money to spend on other things. We can save up to 25% on operation costs each year. This is really good for business, especially in large-scale farms. Environmental benefits, recycled wastewater reduces the amount of wastewater released into the environment. This prevents water pollution. In this way, greywater use reduces the water footprint of livestock farms by 35 to 45%. By implementing greywater systems, livestock farms can significantly reduce their environmental footprint while ensuring efficient resource utilization. For example, in a septic system, there are two compartments, the inlet sides and the outlet sides. How we can obtain greywater? It is an example. There is a baffle, what we call a baffle divider wall between the two compartments with a hole about halfway up from the floor. The solids and wastewater come into the inlet side where the solids break down and settle the bottom. Your fats, oils, greases such as soap, scum, shampoos, and other similar substances will rise to top. In the center layer is the effluent, which transfers to over the outlet sides. The tank is designed so that when you push water in from the source, it pushes the effluent from the center section into the distribution box. The yellow filter is there just in case some solids didn't settle the bottom and are still floating. It catches them as the water comes up. This diagram is an example how the water consumption model for livestock production works. Firstly, the system combines three important databases comprising the WBM plus hydrological model, which analyzes the water usage of crops and irrigated pastures. The model's remarkable detail is owing to its utilization of Faustat data to determine water usage. The most important part of the system looks at how much water is used produced for animals, food for animals. This is checked using GLAM and Faustat trade data. This analysis then separates water used into two groups: water used for animals, water used for drinking. Finally, GLAM protein content analysis is employed to compare the allocation of water across three primary livestock products: meat, milk, and eggs. This approach gives us comprehensive overview of water utilization within livestock systems, including its multiple applications throughout the production chain. This P chart on the right shows the different types of water used in different types of animal feeds and various plants over the world. It's based on FAO region and GLAM. The size of each section of the pie chart is based on the total amount of water used for animal feed. The background colors of the map indicate the different FAO regions. The graph tells us that Eastern and Southeastern Asia together use almost 30% of the world's water, most of which comes from indirect uses. The Southern Asia, most of this water is used to feed cattle and buffalo, especially with crops like maize and cotton that need a lot of water. In Eastern Asia, most of water is used for maize that is then used as feed for pigs and poultry, etc. These pictures a notable example of utilizing biological process in greywater treatment is the role of tiger worms in filtration systems. These worms contribute significantly by breaking down organic matter, particularly fats and residues present in wastewater. In simple charcoal filtration setup, greywater from kitchens, laundries, and bathrooms is first directed into a pre-filtering chamber before passing through layer of organic material and charcoal. With this system, tiger worms actively decompose organic waste, improving water quality and enhancing filtration efficiency. This biological mechanism not only aids water purification but also provides a sustainable approach to managing organic residues, demonstrating how natural process can be integrated into greywater reuse strategies in livestock operation. Greywater in livestock management for irrigation, its utilization in a possibility. Furthermore, it has the capacity to enhance the visual aesthetics of the landscape structure in the vicinity of the enterprise, utilizing treated greywater for pasture and fodder crop irrigation. For toilets, it can be used. It's in toilets used by people who work in business, farm facilities for sanitation purposes. It says water, clean water, is good for keeping the toilets clean. And facility cleaning using greywater for cleaning barns, milking units can reduce the amount of fresh water, clean water used in dairy farms by up to 40%. Greywater can be used for cleaning various equipments, non-food contact surfaces, washing the floor, various for equipment cleaning, for example, reduction the reliance on freshwater washing barns and equipments, for example, cleaning and sterilization of equipments, vessels, efficient recycle of liquid waste is crucial in sustainable farming. Greywater can be incorporated into waste management strategies to reduce overall water consumption. This approach aligns with modern agricultural sustainability goals by in the summer, for example, water becomes integral part of cooling system. The utilizing of greywater in the cooling system with an especially intensive livestock enterprises, is capable of reducing total water consumption, clean water consumption, by up to 35%. Another practical use of greywater is for bathing animals, particularly in regions facing water scarcity. Then, when properly treated, greywater can be a safe and effective alternative to fresh water for maintaining animal hygiene. However, it's essential to ensure that contaminants such as detergents or chemicals are removed to prevent health risks. The utilization of treated greywater for external cleansing or cattle is permissible, provided that adequate treatments and disinfection procedures are implemented. Nevertheless, it is imperative for refrain from eye and mucous membrane contact. Sheep washing and wool cleaning for sheep washing and wool cleaning, while the employment of greywater in wool washing process in sheep does result in water conservation. It has the potential to compromise wool quality due to presence of detergent residues. Consequently, the recommendation is for additional rinsing to be undertaken. It's imperative to exercise caution when considering the utilization of greywater as a source of drinking water for animals. Greywater is not deemed suitable for direct consumption by animals. The salient points in this regard are follows with regard to health risk: presence of detergent residues in greywater, risk of microbial contamination, presence of heavy metal and chemical residues, presence of hormone and drug residues. For example, phosphates and parabens, common in detergents. These chemicals may affect animal skin health, wool health, mucous health, and metabolism. Bleach and synthetic fragrance can cause irritation or allergic reaction if exposure is prolonged. To mitigate these risks, to protect these risks from these risks, proper treatment and monitoring of greywater are essential before its application in animal husbandry. Adverse effects on animal health may be observed, potentially resulting in yield losses. This demonstrates the potential for long-term economic damage. According to Thompson et al., the presence of chemical residues in greywater, including detergents and cleaning agents, can cause several gastrointestinal disorders in livestock. And the other one, Martinez and Kumar, according to Martinez and Kumar, microbiological contamination in untreated greywater poses significant health risk to animals, potentially leading to reduced productivity and increasing mortality rates. And the other one, Anderson et al., according to Anderson et al., studies have shown that even low concentration of household chemicals present in greywater can accumulate in animal tissues over time, potentially affect both animal welfare and product quality. According to WOAH guidelines, the World Organization for Animal Health strictly prohibits the use of greywater as drinking water for livestock due to potential contamination with pathogenic organisms. And several countries have successfully implanted greywater systems in livestock production. For example, Netherlands, dairy farms widely use greywater for cleaning and irrigation. Australia, sheep farms utilize treated greywater for irrigation, reducing dependence of fresh water. And Israel, ovine breeding, small ruminant breeding systems have integrated treated water into farm operations, demonstrating its feasibility for animal production. This case study highlights the potential of greywater use across different livestock sectors, different regions, different countries. The use of greywater contributes to sustainable future in animal husbandry. Investment costs should be taken into consideration, and animal health should always be a priority. The use of greywater in livestock farming presents a viable solution to address water scarcity and promote sustainability. Moving forward, key recommendations include improved treatment methods, ensuring water quality for safe application, policy development, establishing regulation to guide greywater use in agriculture, farmer awareness and training, encouraging best practices for effective implementation. With these measures, greywater recycling can become a standard practice in livestock management, contributing to water conservation and environmental sustainability. And as we know, water is life. Thank you for your listening.
Thank you for your presentation. They are two excellent examples for the greywater. Thank you. And who is the next?
The next one is my colleague Cenk will present about use of greywater in crop production. Yeah, Cenk, it's your turn.
I'm sharing my screen.
Yeah, please.
Yeah.
Can you see it?
Yes. Yeah,
Okay.
nice.
Hello everyone, welcome to my presentation. Now I will discuss the implications of greywater usage in farming practices. In this presentation, I will explore the risks, contamination levels, effects on crops, plant health, and pest management related to greywater use in agriculture. The use of greywater in agriculture can introduce pathogens and contaminants that may pose health risks to both consumers and farmers. Therefore, it's crucial to assess these risks comprehensively before implementing greywater irrigation. Additionally, greywater can have significant environmental impacts, particularly on water quality. Identifying these impacts as essential for ensuring that greywater usage aligns with sustainable agricultural practices. By understanding these risks, we can develop effective mitigation strategies to maximize the benefits of greywater while minimizing potential health and environmental concerns. To ensure the safety of greywater for agricultural use, it's important to analyze the types and level of microorganisms present. These microorganisms could pose risks to plant, animal, and human health. It may be Fusarium and alternate species, like soil-borne fungi species, can also bacterial pathogens like Pseudomonas and Xanthomonas species. One of the key considerations when using greywater in farming is its effect on crop yield and quality. Some studies suggest that greywater can provide additionally nutrients that promote plant growth, while others warn about potential risks due to contaminants. Another important aspect to consider is the long-term effects of greywater on soil health. Over time, the repeated use of greywater may soil composition, leading to change in fertility and structure. By analyzing these effects, we can better understand how to safely integrate greywater into agricultural practices without negatively impacting crop health. Okay. Beyond crop yield, greywater usage can also influence plant health and resistance to diseases. To begin, different irrigation methods can significantly impact plant disease resilience. Some methods may help reduce disease risk, while others could increase it, depending on how water interacts with the plant leaves and plant roots. Uh, nutrients in greywater may contribute to improved plant growth and even enhance disease resistance. However, these effects varies depending on the composition of the greywater used. The trends in greywater usage are evolving as interest in sustainable farming grows. More research is being conducted to identify the best potential risks and practices associated with greywater use in agriculture. Greywater irrigation not only affects crop growth, but also plays a role in plant disease resistance. The way irrigation methods distribute greywater can influence how disease spread in crops. Understanding these effects is crucial for developing effective farming practices. Additionally, nutrient contributions from greywater can have both positive and negative effects on plants, while nutrition may make stronger plant defenses. Contaminants could weaken them. By studying these factors, farmers can make informed decisions about how to use greywater effectively in agriculture. Greywater may also influence pest populations in agricultural fields. There is a complex relationship between greywater usage and pest dynamics. Elements in greywater may attract certain pests, while others might put off them. Understanding this relationship is important for integrated pest management. Additionally, comparing different irrigation strategies can provide valuable insights into how various watering methods, including greywater use, impact pest control efforts. Finally, greywater can have broader ecosystem effects on pests, which could influence overall pest management strategies in farming environments. Greywater plays a significant role in sustainable farming practices by offering an alternative water source and, in some cases, enhancing plant health. Assessing key plant health indicators when using greywater allows farmers to optimize their management practices. This type of analysis is crucial for improving crop yield and sustainability. Recent research findings on greywater use in agriculture highlight both benefits and risks. So on the one hand, greywater can contribute to water resource conservation, reduce reliance on fresh water, and provide additional nutrients. On the other hand, uncontrolled use may introduce harmful pathogens or chemical residues into the soil, impacting long-term agricultural sustainability. Greywater can be valuable resource in sustainable agriculture if used correctly. The key benefits of greywater use include water conservation, potential nutrient contributions, increased sustainability. In conclusion, greywater presents both opportunities and challenges for modern agriculture. Its reuse can help address water scarcity, promote sustainability, and even contribute nutrients to crops. However, it must be carefully managed to avoid potential risks to human health, soil quality, and crop health, obvious. Future research and policy development will play a crucial role in ensuring that greywater is safely and effectively integrated into the agricultural system. Thank you for your attention.
Thank you, Cenk, for the presentation. Yeah, it's nice. And we have one more presentation. It's, I think, from Ferda Nur Özdemir.
Yeah, Ferda will present in my computer.
Yeah. And during the presentation, if you have some questions or the comments, you can write on the chat. Then after that, we can discuss.
That's okay. Could you see my screen?
Yeah, this is good.
Dear Almudena, dear Taner, and dear young researchers, my name is Ferda Nur Özdemir Keskin. I am a PhD student, Faculty of Agriculture and Department of Agriculture Economy. Before starting, I would like to state that I'm a little sick. Sorry for my voice. I connected from my phone because there was a problem with my computer, but I will make the presentation from my teacher Ulku's computer. I will present about economic investigation of the use of greywater in agriculture. In this presentation, we will take an in-depth look at the economic aspects of greywater use in agriculture, from the financial burden of current irrigation methods to greywater treatment technologies. Evaluating the financial benefits of greywater systems, analyzing financial returns from greywater use. This section will focus on quantifying the financial returns that can be expected from implementing greywater systems in agricultural practice. Exploring economic advantages of recycled water, understanding the broader economic advantages of integrating recycled water in the farming operation is crucial for maximizing resource efficiency. Assessing cost effectiveness of irrigation alternatives. In this part, we will compare the cost effectiveness of greywater irrigation systems against traditional irrigation methods, considering various economic factors. Economic assessment of recycled water in farming, exploring market trends for recycled water, understanding current market trends and their implication for the adoption of recycled water in agriculture is vital for information decision making. Economic burdens of current agriculture methods, irrigation methods. The first, high water bills depends on means water leads to high utility bills. This problem is particularly acute in arid regions. Second, energy costs. Transport and pumping of water increases energy consumption. This increases the cost of agriculture enterprises. The three, depletion of water resources. Over irrigation causes groundwater levels to drop. It threatens the sustainability of water resources in the long term. Greywater treatment technologies and costs. Physical purification, biological purification, chemical purification. The first, physical purification, simple filtering methods are used. Its cost is low, but its effectiveness is limited. Biological purification, treatment is carried out by means of microorganisms. It is more effective, but costs more. Chemical purification treatment is achieved by using chemical substance. It is the most effective method, but is the most costly and carries environmental risks. The effect of greywater use on agricultural production costs, reduction in water costs, optimization of fertilizer use, increasing productivity. The first, dependence on maize water is reduced. This provides significant savings in water bills. The second, optimization of fertilizer use. Greywater contains nutrition for plants. This reduces the need for fertilizer and reduces the cost. Increased productivity. Correctly treated greywater improves plant yield. It increases productivity, resulting in higher income. Impact of greywater use on water bills and network dependency. Decline in water bills. The use of greywater reduces the need for maize water. This is directly reflected in water bills. Decrease in network dependency. The risk of being affected by water cuts is reduced. Water security is provided, especially in dry periods. Sustainability, water management. Water resources are used more efficiently. Water resources are protected for future generations. Investment analysis of greywater farming techniques, evaluating financial returns on greywater investments, understanding the potential financial returns from investing in greywater farming can guide stakeholders in making informed decisions. And cost-benefit analysis of agricultural water reuse. A thorough cost-benefit analysis of agricultural water reuse provides insights into the economic viability of greywater practice. Case studies, economic gains of farmers using greywater. A farmer reduces irrigation cost by 40% by using greywater. It's achieved a 20% increase in production efficiency. And another farmer has completely eliminated his dependence on maize water thanks to greywater. He avoided being affected by water cuts. Case studies Case studies, economic gains of farmers using greywater. Project in Israel, Australia, and Spain demonstrate the economic and environmental benefits of greywater irrigation. These initiatives have led to significant water and energy savings, improved crop yield and quality, and faster return on investment. Challenge such as deposition, pH imbalance, and microbial contamination. Microbial contamination were successfully addressed through advanced filtration, pH regulation, and UV disinfection systems. Socioeconomic effects of greywater irrigation practice, addressing public health concerns, and understanding the public health implication of greywater use in agriculture is crucial for evaluating its socioeconomic impact and acceptance within communities. And government policies influencing greywater use, government regulation and support can play a vital role in shaping the socioeconomic landscape of greywater irrigation, impacting both farmers and consumers. Impact on local communities and farmers. The introduction of greywater irrigation practice can have significant socioeconomic effects on local farming communities, affecting livelihoods and employment opportunities. Community engagement in irrigation practice, engaging local communities in discussion about greywater use, can enhance awareness and lead to better adoption rates, thus improving economic outcomes. Conclusion and recommendation: economic potential of greywater use in agriculture, economic benefits and environmental benefits and sustainability. The use of greywater in agriculture offers significant economic benefits. It also has great potential in terms of environment benefits and sustainability. It's possible to further increase the potential with government incentives and awareness-raising activities. Thank you for listening. Participate.
Thank you so much. Yes, if there are any comments on the questions, please write on the chat group. For now, just I can ask, do we have any example in Turkey, or do you know about using the greywater in agriculture?
We didn't hear. Taner, could you repeat that, please? The question for...
Sorry. So,
Yeah.
I wonder, do you have any example in the Turkey to use the greywater?
Not now.
Not now. Okay.
Yeah.
What is your suggestion? It's for controlled by the regional or municipal or governmental? Which one is easy? Or
At the first, it is easy for housekeeping. I mean the toilet phones. For example, from the machine, we can collect this water and we can use this in toilet reservoirs. Not needed any filtration and not needed any purification. It can be used at the first place. And the second one is we can use this in farm for the green areas. For example, management the flowers. For example, management the outside green areas. We can use this in farm. These are easy.
let's see.
Mm-hmm.
And yeah, it also improves the yield of the products.
Yeah.
So it was nice, and there are no comments. I'd like to again thank you to all presenters. This is our first forum,
Yeah.
and yeah, the first one is with agriculture, and it's luckily you are from the same institute. Maybe you can say about your institute and Erzurum. So it's a bit different. Maybe everyone knows Istanbul, Antalya or something, but so
Yeah.
it's also very historical and touristic place. I know because my background is from also Turkey.
All
So
of
just
we
for
are
foreigners.
all of we are at the same faculty of agriculture. Doğan and I in the Department of Animal Science. Cenk is in the plant protection, and the Ferda is Department of agricultural economy. And the Erzurum, our university name is Atatürk University, and it's east of the Turkey, and our city good in the winter because we have center in this region in our city. And if they are interested students to visit us for the STSM or Erasmus, we can say welcome all of the students in the next times. We love our institute and we love our university. Is there any question I
That's
can
very
answer?
nice.
I don't know whatever I can say.
Yeah, I would like to come and visit you, but I'm not working on the agriculture or greywater.
Yeah, why not? We can collaborate, all of us.
Yeah, that's nice.
Yeah.
So okay, then I guess we can stop it and thank you again for your attention. So see you in the next forum. Thank you so much.
We hope so. Nice to meet you so
Nice to
much.
meet you.
Thank you.
See you again.
Thank you.
Bye.
Bye.